Hey, this is Kyle with Simulation Lab, and in this tutorial, I'll show you how to create this sick skateboarding game in Unity called PizzaSkater. It's based off of one of my favorite games called Night Skate by Odd Animal, which I totally recommend that you check out. For our game, there's links below to get the art assets as well as a GitHub link in case you get stuck. Let's write some code and get skating. Okay, let's jump into it. So with my Unity hub open under projects, we'll go ahead and click create new project. We're going to choose the 2D built-in render pipeline, and then we'll name our project something. I name mine PizzaSkater. And you'll choose where you want to save the project. In this case, I've already created a project. You can uncheck connect to Unity Cloud because we're not going to be using that feature. And then go ahead and click create project. To save a little bit of time, I've already done this. So I've created a blank, empty project, and there's nothing in my scene. In the project assets explorer window down here, I've created a folder called sprites. If we open that up, we'll have several separate subfolders, one for buildings, one for props, like cars and stuff that he picks up and all that. One for roads, this is what he's going to be actually skating on, and our PizzaSkater sprite sheet. So you can find a link down below to download these assets and import them into your blank project if you want to follow along. So if we go ahead and drag our character sprite sheet into our scene, we can check it out. So this is these are basically just several like little animations for this character that are all kind of stitched together in one sprite sheet. So we're gonna have to chop this up into a series of animations. This is my favorite little guy right here. When he does a little spin around, you can see his butt. Anyway, so we'll go ahead and delete the sprite sheet out of our scene, and we'll get started slicing this sprite sheet up. So if we click on the sprite sheet, in the inspector window, you can see that this is imported as Sprite 2D and UI. And if you're using Unity 2022, this should automatically be defaulted to Sprite 2D and UI. But in case it's not, if it's default, then you'll have to choose this, Sprite 2D and UI. It just depends on which editor version you're using. Under Sprite Mode dropdown, we'll have to choose Multiple, which will allow us to slice this up. And we can go ahead and hit apply, and then we'll click on the sprite editor. So this will allow us to basically chop up our sprite sheet. And now under the slice dropdown, there's a type here. Instead of automatic, we'll do grid by cell count, 8 columns and 7 rows. There we go. What I want to do is slice each sprite by the bottom of the wheels, basically like where he's standing. It's going to make it easier for us to just like kind of, work with the character that way. So what I'll do is in the padding, I think we'll adjust this and probably put it something, I think like 23 will do it, something like that. And we can always make adjustments to this later. So with that set up, we'll go ahead and hit slice. And then you'll see those the boxes around each character frame are sliced, and we go ahead and hit apply. And we'll close this out. Okay, so now we've sliced up the sprite sheet, and when we tap on this little arrow right here, we can see each individual sprite that's broken up. We can even click on each one of these. We can even drag these into our scene, which is pretty cool. Right? So I'll just delete that for now. What we're going to do now is start setting up some animations. Right? So let's take the first 3 frames here. We'll right click and then go to create, and then we'll go to animation. And we'll have to entitle this something, so we could just call this idle. And then I'm going to create a separate folder, just basically back in my main assets folder. Right click, create folder, and I'll call this animations. And then back in my sprites folder, what I'm going to do is grab this animation and I'll just chuck it in this animations folder. And we'll continue doing this for the rest of the animations. So next up, we'll do this little basically like this little jump grab animation. So I think it starts about here where he crouches down and then ends here when he's back at the sort of idle stance. So I'll grab all of these frames, do the same thing, right click, create animation, and we'll call this jump grab. And similar thing, I'll just chuck this in animations folder, and I'm going to speed up the video here and just complete the rest of these animations. Okay, with all of our separate animations set up in our animations folder here, right now they don't really do anything, so we need a controller that controls all the animations, right? But first thing we're going to do is we're going to grab all of these and then we're going to check loop time if it's not already checked, right? So we'll click on loop time and then we'll right click in our animations folder and hit create and create animator controller, right? And we'll call this player anim controller, right? We'll open up the animator controller and that'll pop open this animator window, and we have three sort of default states that the controller comes with. There's the any state, there's entry, and there's exit, right? And we're only really concerned with the entry state for now. What we're going to do is we're going to set up three separate states. One of them is going to be for idle, which is basically like he's always going to be skating in like the same direction. So it's just going to be like an idle state where he's kind of like bobbing up and down, cruising down the road, right? And then there's going to be a state for jumping, which will have like sort of several random animations. Basically, like there's the animation for him like doing the grabs or like doing the kick flips and stuff. So we'll set that up in the jump. And similarly with the grind, there's like two different grinds. There's like the nose grind and the tail grind, right? So we'll have to set up those as separate states. So the first thing we can do is go ahead and create an empty state. We'll name this state idle. And then under the motion, we could just chuck our idle animation in there because we just have one idle animation. And then in the speed, we can adjust this to like 0.5 or something. We'll just like test some stuff out and see how it works, right? And then for the jump and grind states, what we can do is we can right click, and instead of creating an empty state, we can create from new blend tree. And I'll show you what this does in a second. Basically, a blend tree will allow you to blend between different animations or sort of choose random animations in our case. So we'll name our blend tree, I guess we'll do jump first. All right. Cool. And then we'll just leave the speed at 1 for now. We'll just test this stuff out and see how it looks. If we double click on our jump state here, we'll open up the actual blend tree window, right? So we can chuck in some of our animations here. So what we'll do is we'll right click on our blend tree and we'll click add motion, right? So that'll populate this little field here in the inspector. We can grab our jump grab, we'll put that in here and it'll pop it open in the blend tree here like this. Okay, so we'll right click again, add motion, and then I'll create a new one and we'll do the jump, I guess the jump kickflip, right? And we'll just continue doing the same thing for the rest of the jump animations. So now we can see this threshold value is grayed out, but we're going to need to use that in order to choose between these different motions, right? These different jumps. So what we'll do is under the parameters tab, what we'll do is we'll create a new, well, we already have one set up here. It's called blend right now. We can rename this something like a jump type, right? And now if we uncheck this automate thresholds checkbox, now we can assign different thresholds to each of the individual jump animations. So we'll just do that now. So we'll leave jump grab at 0, jump kickflip will be 1, jump misty flip will be 2, and jump spin will be 3. Oops. 1, 2, 3. Yep. So 0, 1, 2, 3 for jump, misty, kickflip, and spin, right? And we'll leave all of the timing, the animation speeds at the default 1. Cool. So with that set up, what we'll do is we'll head back to our base layer, and we have that jump set up. What we could do is right click and hit make transition, and we'll transition to the jump. If we click on our little arrow here, we'll uncheck has exit time because we just want it to instantly go to that from idle to jump whenever we trigger the jump, right? And we currently do not have any conditions set up. So we'll go ahead and create a new parameter that'll be, our condition, and it'll be a bool, basically true or false, if the character is jumping, right? So we'll call that is jumping, and then back here in our this little arrow here under the conditions, we'll just choose is jumping, and we'll say that's true, right? So from idle to is jumping, that's gonna start the jump animation, right? If is jumping is ever true, right? We'll show you how to control all this stuff later, but right now we're just kind of setting this stuff up, right? From jump, we want to be able to go back to idle, right? So we'll do make transition, and we'll go back to idle. We'll click on our little arrow here, and in conditions, we'll say is jumping is false, right? So now we'll create a new state. So under create state from new blend tree, and we'll do a similar thing for the grind animations, right? So here we'll just call this one grind. If we open up our animation state, similar thing, add motion. Click on our blend tree here, and we'll do the grind nose, add motion, grind tail, right? We'll uncheck animate thresholds. This is going to be 0 and 1. We'll create a new parameter, a new integer parameter, and we'll do grind type, right? So similar. We'll be able to control these. This basically the thresholds are like the different animations within this blend tree by using that grind type, right? Okay, so now we have our grind type set up. What we need to do is assign it to this parameter. So instead of jump type, we can just type grind type. Right? So if we go back to our base layer, we'll just review this once again in our jump blend tree state. If we double click on that, we click on blend tree, our parameter here is jump type, and that's 0, 1, 2, or 3 for the different jumps. If we go back to the base layer again, we'll go into grind, similar thing, click on our blend tree, and make sure this is set to grind type, which corresponds to this parameter value here. So that'll be able to talk to this blend tree and tell it either it's going to be a nose or tail grind, right? Cool. So now from idle, we'll make a transition to grind. So we'll right click and hit make transition, and we'll click on grind, right? And then what we need to do is create a separate bool parameter here to basically once basically like is grinding is checked, then it'll go to this blend tree. So we'll hit new bool parameter, and we'll do is grinding, right? We'll click on this transition here. We'll uncheck has exit time, and of course we need to add our condition. So instead of that, we'll do is grinding, and that's going to be true. And the similar thing, back to idle, we'll right click, make transition back to idle, and we'll click on this, does not have an exit time, and we'll do is grinding is false, right? Cool. So now one cool thing that we need to do is we need to add a transition between jump and grind, right? So we'll right click on jump and hit make transition, and we'll go to grind. We'll say is jumping is false and is grinding is true, right? And then same thing back from grind to jump, right click, make transition. We'll click on our arrow, uncheck has exit time. Again, it's very repetitive. We'll go from is grinding, we'll make sure this is false, and then is jumping is true, right? So that basically allows the character, when he's grinding, he can also jump and transition to, a jump animation, and vice versa, right? Now that we have our Animator Controller set up, let's continue working on our character and actually get something cool to start happening here, right? So let's go ahead and open up the sprites folder, and we'll grab our first frame of the character here, and we'll just put that in our scene somewhere so we can work on him. Maybe we'll just like zero him out. So I'll just right click on the transform and hit reset, and that'll zero the position out, because we could probably make this guy into a prefab. But what we'll do is we'll just rename this. So maybe we'll just call him player skater, something like that, right? And what we'll do is we'll start building out a character, right? So under add component, I'll add, let's see, animator. And on our controller, we just have the one controller, so we'll go ahead and assign that. We'll leave avatar blank. I'll apply motion. We'll just leave all the rest of these default, right? Let's continue adding some stuff here. Maybe we'll just put this animator at the top, right? because this sprite renderer doesn't really matter, because that's going to be changed, you know, at runtime. So under order and layer though, we'll just set this to something like really big, like 10. Because basically we want the character to always be rendered on top of everything regardless, right? So we'll set that to 10 for now. Under tags, we'll just assign this to be the player, right? That's like a default Unity tag that Unity comes with. So yeah, we'll do that. Oh, looks like I got a little error here in my console. It says blend tree is state grind in controller, uses parameter grind type, which is not type float, right? So I need to recreate this grind type as a float instead of an integer value. So that's a little mistake by me, but we'll go ahead and just recreate that as a float value, grind type, right? And that should take care of that that issue there. So we'll clear this out. Anyway, back in my scene, let's continue working on our skater dude. Yeah, so with our sprite renderer set up, we got our order and layer 10. We'll just, we can collapse that. Next step, we're gonna need a box collider, so he can collide into the ground and other things. Eventually we're gonna be doing some pretty fun stuff, so we'll hit ground collider 2D. And we can edit the collider. We can kind of drag this down, and basically we want it to be the bottom of the collider to be at the bottom of the wheels, pretty much. But what we can also do is add a little bit of an edge radius, because if it's completely square, it might catch on stuff, and you know, it's just like it's just gonna maybe act a little bit more nicely if we give it a little bit of an edge radius at the bottom, but we don't want like too much. So maybe we'll do something like that. Let's see how this works out. But basically, with that set up, we'll put this as close to the bottom of the wheels as we can, just to make it look good. We can always adjust this stuff later. You know, maybe we'll just like kind of drag this out like here. Something like that should be fine. So now with that set up, we'll just do, we'll click this button again to basically lock that into place. And we'll do, we'll add a new component, a rigid body 2D. So that'll allow us to do some physics on it. We'll create a new material. So under, you know what we'll do is we'll right click, create a new folder. We'll just create a materials folder. We might be creating some more materials in the future, so we'll create a folder for these. In our materials folder that we just created, we'll right click, we'll do create 2D, physics material 2D, and we'll just call this no friction. Okay. And then under friction, we'll just zero this out. Cool. So with that created, we'll go back to our player skater. In our rigid body 2D, we'll just chuck in our no friction material here. We also want to make a couple more adjustments for our character. I think we're going to probably want to increase the gravity scale to something like 10. Because basically what we're going to do is we're going to apply a force to him when he's jumping. And then this really cool feature that's in Nightskate is like when you hold down the jump button, it like gives it like a sort of lag time, right? So it allows you to like hold down the jump button and you keep flying up a little bit until, you know, like some kind of like timeout occurs, right? So you can only jump for like 2 seconds or something like that, right? And then like when you let go of the jump button or when that timeout occurs, like he comes down really fast, you know? So it allows you to like jump and then slam down on rails and stuff, and it's like super fun, right? So we're gonna do that. So we'll set up gravity scale something like 10 for now, and our collision detection, instead of discrete, we'll do continuous, which is not always a good idea, but for our game being it's very simple, having collision detection be continuous is like probably totally fine because it's 2D and stuff, and it's like a very simple little game. And the rest of this stuff, interpolate, we can do interpolate. I think the rest of this stuff can stay default. We'll just we'll see how it works. You know, game dev is just a lot of iterative stuff. You know. Anyway, so that's pretty much our character generally set up. We need to create a player script to control the movement and all that stuff. So that's what we're going to do now. So before we start creating our script to control the character, what we'll do is we need to add like a little ground test, a little ground trigger test, right? So what we'll do is we'll right click on our player skater, character here, and we'll do create empty, and then we'll call this ground check. And I'll show you what this does in a little while here, but basically what this is going to do is going to allow us to test if the character is on the ground or if he's left the ground. So basically what we could do is with this little guy, we'll just leave this basically empty, but I want to add like maybe a little icon. So I'll maybe give it a little diamond icon or something so we can see it. And what we'll do is we'll just move this up into place, and this is going to be right at the base of the wheels right there. Back in our assets folder, we'll right click and create a new folder called scripts, just to keep our scene organized a little bit. Double click our scripts folder, and we'll right click and we'll create a new C# script, and we'll just call this one player. And if we double click on the player script, it'll open up Visual Studio Code, which is my default code editor. If you're using Visual Studio, this will work just the same. But yeah, anyway, so let's start setting this up. So the first thing we're going to do is we'll just clear this stuff out. The start and update method, we'll create our own later. First thing we're going to want to add here, just to get the character moving and colliding with the ground. So we'll do serialized field, or you can make this public if you want, but I'll create this as a private variable just scoped to this player class. We'll do a layer mask, and then we'll just name this ground layer mask. And basically the reason why we need this is because we only want the player to collide with things that are the ground, right? And then what we'll do is we'll do private rigid body 2D, and we'll just call this rigid body 2D. And this is stuff that the player already has on the character, right, that we just added. So we're just making some references to that stuff. So we'll do box collider 2D. We'll just call this the box collider 2D. And then we'll create a reference to the ground check object that we created as a child component of our character, right? So we'll do private transform. It's just going to be a transform. Ground check, right? And then we need our animator, so private animator. We need an awake method. Basically, we're going to be, we have references stored, all these private references. We're going to need to fetch all this stuff from the actual player, right? Go ahead and assign all this stuff. So rigid body 2D, and we need to get the components from the character. So from this transform, being that this player script is going to be attached to our character, we could just call like transform get component rigid body 2D, right? Same thing with the box collider 2D equals transform dot get component box collider 2D animator we could probably just do get component animator. You don't necessarily need these transforms. Basically, you could just call get component directly, and it'll do the same thing. And then what we're gonna do is we're gonna set up a private bool, call this is grounded, right? And we'll just set that to, well, yeah. And then in our awake method, we can do is grounded equals false, right? So we'll just set that to false by default. Next thing we're going to do is we're going to create a way to move the character. So we can do that in the update loop, which runs once per frame, but being that we're going to be moving the character with physics, we're going to actually be applying a force to the character. We want to do it in fixed update, which runs potentially multiple times per frame, right? So we'll do the built-in Unity fixed update method. What we'll do is we'll create a separate function, private void. It's not going to return anything, and it's just going to be called check grounded, something like that, right? So in our check grounded method, we're going to create an array of collider 2Ds. We'll call this colliders equals physics 2D dot overlap circle all. And we're going to call a reference to our ground check dot position bit of the radius is going to be something like, I don't know, 0.2 f, and then we'll put in our layer mask, so our ground layer mask, right? So that'll give us an array of all of the objects according to ground layer mask, right, that are underneath within that ground check bubble that we created, right? So basically, if that colliders array is ever not empty, then the character is grounded, right? So we'll just for now we'll just do is grounded equals colliders dot length greater than 0, right? So that'll control the is grounded boolean, and in fixed update we'll just do check grounded for now, right? Oops. We'll create this as a separate function to control the actual movement of the character, right? So we'll do private void handle movement. We can scope a variable like a float for like move speed, and we can bring this out to make it public if we want to control it from the inspector. But I think for now we'll just keep this in here. We'll just do something like 5, maybe like 6. I don't know. We'll see how this works, see how fast it goes. And then basically all we need to do is just rigid body 2D dot velocity equals new vector 2. We're going to build a new vector 2, and we're going to say plus move speed rigid body 2D dot velocity dot y, right? So that's going to allow us to apply velocity to the character in the sort of like X direction, right? So it's always going to be going in the positive X direction. And then what we could do is just grab this, we can do handled movement, and we'll just chuck this right in here in our fixed update method, right? Cool. So now if we apply this to the character, what should happen is that he should start moving, right? But he's not gonna like go anywhere because there's a ton of gravity applied, and we haven't set up anything in the world for him to actually collide with yet. So we'll do that next and see how this stuff works out. So I'll go ahead and save our script. We'll go back to Unity, and in our player skater character, we'll scroll down here and we'll just player script that we just created onto our player, right? In our ground layer mask, we need to create a ground layer. So what we'll do is back up here in layers, we'll do add layer, and we can just put this in here as ground, right? Back in our player, now we can assign the ground layer here, and then also the ground check. We need to put this in here, ground check. So now if we save our scene, if we hit play, basically we should see our character like immediately drop to the ground. He's gonna fall forever. Yep, see? All right, cool. So let's give him something to collide with now that we know our script is sort of working. So back in our sprites folder, let's create a first little road, right? So we'll double click on our roads, and I guess I'll grab this like road flat 02, the really big one, and we'll just chuck one of these in our scene. Let's just quickly, just for testing purposes, let's just like grab a couple of these, and I'll just like put one here, and I'll add a box collider 2D. And we'll adjust the collider to be sort of like in the middle of the road, something like that. And just to test and see like how this is actually working, I'll just grab this and I'll duplicate this, and we'll just like move this over here. And I don't care about it being perfect. I just want to see like what is actually happening with the character, right? Cool. So with that set up, what we need to do is grab all of these, and we need to put these on the ground layer, right? Okay, with our player script attached to our player and our ground layer mask set to ground, let's play it and see what happens. So now we can see our little skater dude, and he falls off the map, which is great. So he's moving a little slow, and we can always adjust that move speed. We might expose that to where we can control that in the inspector, and then maybe during the course of the game we can even make the speed a little faster, like it just continuously goes faster or something. So there's a lot we can do with that. But just for now, what I'll do is in our player character, I'm gonna uncheck this just to check our animations. So basically what we can do is we hit start now. It's not gonna go anywhere, but our animator should still be working. So he's just gonna stay right there. And then in our animator, what we could do is like, we can check is jumping. And then, so yeah, there we go. So he's like doing a little grabby jump. We could probably adjust the animation where he's like only grabbing, right? And what we can do is check out the grinding. So grind type is 0. Okay, so we can adjust that animation a little bit because it looks like he's kind of jumping off the rail. Maybe we just like want the 2 frames or something. So what I'll do is back in our animations folder, the grind nose, we'll pop this open and we can drop this down. We can sort of see the different animations. So maybe I'll just get rid of like this one at the end, right there. And we'll see how this looks again. Okay, is grinding, and we'll leave that at 0. Yeah, that's looking pretty cool. We can always adjust that like little wiggle he has, but I kind of like that just because it looks like he's like kind of grinding on a rail, you know? So yeah, we'll just leave the wiggle in. I kind of like how imperfect it is. So now that we have our player generally set up, for now at least, let's get the camera following the player. Because currently when we play the game, it just, the player will just like cruises off the side of the screen. And obviously we need the camera to be able to follow the player. So now there's 2 different ways we can go about doing this. One way is we can use the built-in Cinemachine engine that's within Unity. What that'll do is follow the player. We can do all kinds of cool stuff with it. However, we want some custom logic here. We want to be able to follow the player until a point that he either dies or he gets hit by something. Let's say, for instance, if like he gets hit by like a car or he hits some kind of obstacle. I want the player to stop and I want the camera to continue moving, right? So he kind of goes off screen. That's kind of how they did it in Nightskate, and I thought that was a really cool little trick. So we'll have to create our own like little custom logic for our camera movement. So let's right click in our scripts folder and do create C# script, and we'll call this camera follow. Okay, we'll double click our script to open it up. And then we'll just delete everything except for the update method here. So first up, we'll do public float, and we'll call this follow speed. This is like the speed of how fast the camera is moving. We set this as something like, I don't know, 2 for now. And then we'll do a serialized field, and this is going to be a private transform. And this is going to be the target, right? So this is basically going to be our player, or whatever we want to, whatever we want the camera to follow. And then we'll do a public bool fall behind cam. I'll set that to false for now. The player falls behind, the player dies or something like that, the camera just continues, right? And so in our update method, basically we could do a conditional check. So like if the target still exists, if it's not null, and we haven't fall behind camera. So like if fall behind camera is false, we're going to create a new vector 3. It's going to be called the new position. So we'll just do new pose equals new vector 3. So we'll build a new vector 3 here based on the target.position.x plus like a little bit of a buffer, maybe 1.25, something like that. We'll see how this value affects the target, the sort of position while the camera is following the target. And then we'll do target position.y divided by some value like 8, something like that. And we could just do like -10f for z value, basically like how far the camera is away from the player, even though that's controlled by other things, but we'll just put that in here for now. And then we want to use that new value, this new pose value, to control the transform of the camera. So transform.position equals vector3.slurp. So we're going to slurp is smooth linear interpolate. So basically going from one position to another position. And we'll do transform.position, and then the new pose. Float value here is the time. It's basically like the speed of the linear interpolate, right? So we'll do like follow speed times time dot delta time, right? And then we'll do an else here on this conditional statement. So otherwise, we want to continue moving the camera. So we could do transform dot translate. Translate. If I can type. Vector 3 dot right. So we just want to go continue going right. Times time dot delta time. And then times a follow speed, right? You know what we'll do is we'll divide follow speed like by 2 or something, so it's not so fast, because it's going to be pretty fast, right? And then we'll put those in brackets like that. Yes. So I'll go ahead and hit save on that. Let it compile in Unity. And then we'll grab our main camera object and we'll chuck our camera follow script right here. And then for our target, that's going to be our player skater, right? It's going to be our player. So now we can adjust this follow speed, but let's just see what this looks like. So I'll go ahead and save the scene and hit play, and we should see our camera starting to follow the player as he's moving. Right? Cool, so there we go. And now he's like a little bit further ahead. So what we could do is adjust this follow speed to something like 10, because effectively we want the camera to move a little faster than the player, right? Because we want the player to be kind of like on the left side of the screen so you can see more obstacles coming up. So we'll go ahead and see what 10 looks like for the follow speed. And yeah, that's looking pretty good. I mean, he's like not directly in the center of the screen. We can set that a little higher if we want to, something like maybe like 12. I don't know. We could just continue messing with this. Okay, so now that we have our camera following our player, let's set up some UI buttons, right? Some UI, and then we'll create a game manager, and so we can like start and stop the game, and we can jump and stuff like that. First up, what I'm going to do is I'm going to grab this game window, and I'm just going to drag this to the side of the screen here so we can see both at the same time. Another thing we can do is instead of free aspect, we can choose like one of our phone aspect ratios. So if you don't have these in here, you can always create a custom one, and you can label it whatever you want, and you can create the width and height dimensions of your phone. Under our camera, we could adjust the size a little bit so we can like see more or less of the world or something, but I guess we'll just leave that at 5 for now. Anyway, let's create a button, Text Mesh Pro, and we're going to have to import the TMP essentials. So let's go ahead and do that. So now we'll see our UI, and it's this tiny little button right there. And we click on our canvas. Let's configure a couple things here. Right now it's set to constant pixel size. We can do scale with screen size, and we can set up our aspect ratio, and we can do the same aspect ratio we have in our viewport here if you want to. So X is 1284 by 2778, something like that. Match width or height, and we can do, I usually just do 0.5 here. So that'll allow us to adjust the ratio of your screen size changes, right? So this first button here, let's kind of like position this like somewhere in the middle of the screen. What we can do is type T. You can adjust our transforms, and we can just like drag this to the size of the entire screen, and then we can like shrink it in a little bit or something. This will be maybe like our start button. Put that down here. And then what we can do is in the text, grab this text. Of course, we want to increase this font size a little bit. This will be our start button. Start. Or you know what? We can say play, right? Cool. Maybe we can choose a different color for our button. So in the image of the actual button and the color, we can choose something like green or something. Like that. And then maybe we'll just make this bold and make this like white. It makes it a little easier to see. Or you can even adjust the pixels per unit to kind of give it a little bit rounded, like a lot of rounded edges or something. It looks kind of cool. All right, so we have a play button, and we'll just rename this, and we'll do button dash play. And then we'll do Control D. We'll duplicate the button in the same spot, and we'll do this will be the button for jumping. Jump. Right? And in our inspector, if we grab our play button, we just hide that for now. We'll be able to do some modifications to our jump button, right? So maybe our jump button can be a different color, like orange or something. And we'll rename the text to be jump, right? Cool. And so at the start, the jump button is going to be hidden and the play button is going to be visible, right? So we'll create a game manager script that'll control all of that logic. So in our scripts folder, we'll right click, do create new C# script, right? And we'll call this game manager. And we'll double click game manager. open that up and we'll just clear everything out of here for now. First thing we'll make reference to is our player. So we'll do private player. And above here, we'll do some references to our UI. So in order to keep things a little tidy, we can create a header so we can see that in the inspector. So do square brackets and then type header. And then we can name the header something like UI refs, something like that. That'll just keep things a little organized for us in the inspector. And then we'll do a public button. And we'll call this the start game button. If you're missing a package or a library imported into your script, what you can do is, so I don't have the UI namespace referenced in the script, so I can double click and I can do control period. And then it'll show me my quick fixes and I can choose unityengine.ui. So that'll allow us to create buttons, button references. Do another public button, and this will be the jump button. Right. Do awake. In the awake method, we'll just do this for now. So like skate player, sorry, for the player, we'll just do find object of type. This will just find it in our scene, and the type will be player. The reason why I'm doing that is just because we might reuse this game manager in different levels and stuff, and like it's just gonna save us a little bit of a headache for like having to reference the player in the inspector. If you're trying to find like hundreds of game objects, then this is definitely not efficient. But if it's just one game object, and especially if it's like at the root of your sort of scene hierarchy, then using find object of type is actually quite efficient. So let's do a start method. Maybe just like make sure this start game button dot game object, set this active. Make sure that's set active to true. And then similarly, our jump button dot game object that's set active. I want to set that to false, right? And we might come back to the start method and add some more stuff later on as we build more logic into our game. Now we want to create a new public function that we can call from our start button. Public void, it's not returning anything, and we'll just do start button. Okay, and basically we're going to do the opposite of this stuff with our UI, right? So I'll copy and paste that down here. That start button is going to be now false, the jump button is going to be true, and we're also going to have to do some more logic here. When we hit the start button, we want to start the character's movement, right? We want the character to start skating, and before we hit the start button though, we just want him to sit there being idle, right? So the way we're going to accomplish this is back in our player script, we're going to create a new public bool called like has started game, right? And that's going to be default, it's going to be false. So in our fixed update method, if has started game is false, right? Then we're just going to return. So basically what that's going to do is just, it's not going to process any of this stuff. It's not going to handle ground checked or handle movement. So we're just going to basically return nothing if that's false, which it is. We can even explicitly say this is false, right? And so we'll hit save on our player. And that's basically going to stop him from moving until we hit the start button, right? So we can do player dot has started game is true. Pile that back in Unity. We'll hook up our buttons. And what we'll do is we'll create a game object here, create empty game object, and we'll call this managers. That'll host the game manager and some other stuff that eventually we'll start building. We can even put this like kind of up here under the camera or something. So under our managers game object, we can reset the transform to kind of zero that out. And we could toss in our game manager script here. And then we'll put in some of our UI refs. So we'll do the start game button and the jump button, right? So now what we'll do is in our play button, we'll scroll down here to the on-click event. And we can catch a reference to our managers and go to our game manager and say start button, right? And then we'll worry about the play button, or sorry, the jump button in a little bit here. Let's just get this working here. So if we hit save on that, we hit play, our character should just be standing there, idle. Let's drop down. Cool. And now we hit the play button, we should start cruising down the road, right? And of course, our jump button doesn't do anything yet. Okay, so now let's handle the jumping functionality for our character, right? Now that we have the jump button in there, let's pop open our player script here. First thing we're gonna do is underneath the bool for is grounded, and you know what we could do is we can even make this public, and we can even add a header right here. This will be like scene refs. And then here we can do another one. And this is like for jumping. So do public bool is grounded. We'll do another one, public bool is jumping. So like while the character is currently jumping. And then we could do like a private float for like jump velocity. And that's gonna sort of like control how high you can jump. And then we'll do like private float, max jump height. And this is gonna be a hard value set. Maybe we do something like 10. Let's create another private bool on ground reset is false. And I'll show you what that's gonna do later. Okay, so in our fixed update method, we can continue some logic down here for the jumping functionality, right? So we could do a conditional if is jumping is true. We want to change the animation. So what we could do is like animator.set bool, and we have to specify is jumping because that's how we specified it in the Animator Controller, right? And we can say that's true, right? And we'll do rigid body 2D dot velocity equals vector 2.up times the jump velocity, right? We'll do jump velocity minus equals 10, maybe something like 10 times time dot delta time, right? And then we'll say if jump velocity is ever less than or equal to 0, is jumping is going to be false. And then for here, so if is jumping is true, otherwise we want the animator.set bool is jumping. Actually, you know what we could do is just grab this and set this to false, right? And then we need to be able to control that is jumping Boolean with the jump button, right? So let's go ahead and create a new function here called public void jump. We'll just call it jump. So in our jump function, what we'll do is check if he's grounded. Basically, for our game, he has to be on the ground, or he has to be touching something, or either be on the ground or on a grind rail or something like that. So he's got to be on the ground first before he can jump. So we'll do jump velocity equals max jump height, and then animator.set float. And we can do jump type, right? Remember when we set this up, jump type. Here we can just choose a completely random value. So we can do like random.range 0 to, so we'll do 4, I think, yeah. Yeah, I think that's right. If we get any errors, we'll just come back and fix it. And then we'll do is jumping equals true. So that should be all we need to start jumping. So let's hit save on that, and we'll hook up our button for the jump, right? Cool. So in our jump button with selected, we'll go down on click, and we'll grab our player skater, and we'll do player jump. Cool. So let's hit save on that, hit play, and see if he jumps. Hit play, jump. Whoa, cool. But you see that it stops. That's a funny thing. So like if I hit play again, we want him to continue moving forward. So we have to adjust our logic a little bit. Okay, so back in our player script, PizzaSkater player, Okay, see, I see the problem. So we're calling check grounded, which is good. We want to be able to do that before we're able to jump, but while he's jumping, we still want to handle movement. So what we got to do, being that this is fixed update, we're going to grab this and we're going to put this at the end, right? So it kind of, the order of operations kind of matters here. So hit save on that and we'll just test that out. So hit play, and hit our play button, and then when I hit jump, yep, see, that's pretty cool. So it allows him to jump, and then of course he falls back to the ground, right? Okay, so now that we have our player jumping, let's create that sense of like hang time where he can like, while you're holding the jump button down, then he's continuously going up until a certain moment and then comes back down, right? That way you can like jump and then fly up in the air and then slam down on rails and stuff. We have to make some modifications to our button, the way this is working, because right now, every time we just tap that button, it just jumps, right? It just jumps into with one velocity and jumps to a certain height, and that's it. We have to make a new function in our player called land. Basically, that's just going to set is jumping to false. So basically, we'll do public void land. I say is jumping is false. And then that on-grounded reset variable that we created up here, on-ground reset, we're going to also set that to true. And that's something that we're going to handle later. So we'll just make a comment here. We'll do like handle this later. We'll hit save on our character here. And then in the jump button, instead of this on click event here, let's just get rid of that. And then we'll do an event trigger. So we'll put an event trigger component on our button and then add new event type, and we'll do on pointer down. And on pointer down, this is going to be on our player skater, on our player, it's going to be jump, right? So like while that's being held down, it's just going to continuously call that function jump. And then we'll do a new event type on pointer up, I believe. And instead of jump, we're going to do land, right? So let's test and see how that works. So that should allow us to jump a little bit and then land, right? So we'll hit play, jump, cool. I can get like really big air. So let's try that again. So that way I could just jump over small obstacles and I can hold the button down. So if I hold the button down, I get really big air. But if I just like click it, I just jump a little bit. So that's pretty cool. So that allows us to like have that really cool sense of like hang time. Like while you're holding that button down, you go like jump way up in the air and do some flips and do some cool tricks and stuff. Okay, one more quick adjustment I want to make is like when we hit play on in Unity Editor here, you'll notice that like the player is like kind of like further down, and we can't really adjust the camera. We can adjust the Y position of the camera by adjusting the camera follow script a little bit. So let's do that. So basically what I want to do is if I go back into our camera follow, I can create a new float value. So I can do public float like Y adjustment equals 1F. And that will allow us to set that in the inspector. And what I could do is like right here where we're calculating the target Y position, I could just put that in parentheses, and then I can add the Y adjustment to that, right? And we'll hit save on that. We'll compile this back in the editor. So this allows us to sort of like fine tune the placement of the camera on the character. So if I increase that, he goes down a little bit or up, so we can like adjust that. Because in Nightskate, they kind of have it cropped to like a small frame here, which is cool. But I would like to basically be able to see like more or less underneath the bridges, or like more of the city and stuff in the background, which we'll get to later. But it's just kind of nice to be able to control that a little bit in the inspector here. So that looks like a pretty good position, because like when I hit play and it hit big jumps, he like doesn't go so far up to the top of the screen, which there might be some UI and stuff up there later. Okay, so the next thing we're going to focus on is the actual level, right? Because right now we just have these like static road pieces in here just for testing, but we want to like actually procedurally generate those so they kind of last infinitely longer, right? So like it kind of depends on like where the character is at. So we'll do a calculation based on like where the character's position is currently, and how far he is from the last segment, and then just like continue in basically spawning those as the character is moving, right? So for that, we're going to need a level generator script. But before we get into this actual programming of it, I think what we'll do is we'll go into our sprites folder, into our roads, and we'll start creating some prefabs out of these so we can actually instantiate them. So I think what we'll do for here, we'll just get rid of all of these ones in our scene, and then we'll start creating some prefabs, right? So we'll just toss a new one in here. What we're going to need to do is we'll just create an empty game object, and we'll call this like road. We'll just do like road flat 02. We'll copy the exact same name as the one above, right? And we'll reset the transform to be 0. And then basically we're going to grab this element and just make it a child of this. So this is just the sprite. So we can even rename this just like sprite or something, you know. And the way we have to connect these up is a little funny, but basically let's just grab the parent game object, and I'm going to give it a little icon here so we can see where it's at. And I'll grab the sprite and we'll kind of move this up into place, and maybe we'll like connect them based on like the bottoms or something like that. So like we'll something like that might be fine. So like I'm just kind of eyeballing this right now, but you guys can be a lot more precise about it. And then we need to create a separate game object that's going to represent the endpoint. So I think maybe we'll choose a different color. Maybe this one will be blue. And then we'll create an empty game object as a child of our road segment, and we'll call this endpoint, right? And then we'll just drag that guy over and maybe make this red. And we'll align this as best we can to the very end of the segment, and it's okay if it overlaps a little bit. And we'll see how this is starting to look, right? Cool, so then we have that set up. I'll go back in my assets folder here, and I'll right click and I'll create a new folder, and I'll call this prefabs. Okay. And in this prefabs folder, I'll create a new folder called the roads, because we're going to create a bunch of other prefabs, and I just want to keep this organized. So in our roads prefabs folder, I'm just going to grab this parent game object, and I'm just going to, you know what, before we actually do that, I'll create the, we need a box collider 2D. And then I'll adjust this again, kind of like we did initially, and I'll just put this right at the base of the lines, because that's where we want our character to skate on, right? So with that set up, we're ready to make this a prefab. So I'll just go ahead and drag this in here into our prefabs folder, and then we can delete this out of our scene if we want to. But what we can do is like, I'll just like kind of reuse this. We can, you know, what we can do is we can do it prefab and then just unpack, and then we'll just reuse this, right? So I'll get rid of my road segment, go back to my sprites folder, into roads, and then I'll grab the next road piece and I'll just stick that in here. And then we'll have to adjust this. Similar situation here, where we're kind of eyeballing it a little bit. We just want to make sure that it sort of like aligns with that segment there. We'll grab the endpoint and just move it over. And it's okay if it overlaps a little bit. And I'll speed up the video and just complete the last road segments and get everything ready. Okay, so now that we have our prefab road components created, what I could do is I'll just drag out one of the prefabs into the scene, and this will be our kind of like starting position here. So I'll put this guy right about there, and I'll drag him back. Maybe we'll end up creating a few more of these, but basically like this endpoint here is going to be the start of all of the sort of generated roads, right? Maybe we'll even create a separate one. Maybe we'll just duplicate this in our scene. Just to give them a little bit more of a sort of head start here. Okay, so real quick, what I'm going to do is I'm going to create an empty game object just to store like our initial level parts. So I'll just call like level start parts, something, I don't know. And then we'll reset that transform. We'll grab these two segments and just toss this in. That way we could just like collapse that. We don't have to look at it. We might put some like other level start parts in there, you know? So yeah, so we'll start with our level generator script. So under our script folder, we'll right click and do create C#, and we'll call this level generator. And we'll double click to open it up. And for right now, we're just going to get rid of all this stuff in here, and we'll start with, let's start with like a private float that determines the distance from the player to the last spawned part, right? So we'll do like private, and we'll maybe make this a constant variable that like won't change. And we'll just, my constant variables I like typically like to write in uppercase, so like player distance spawn level part, something like that, just so I know exactly what this is. We'll do something like 200 for now. We'll figure that out. So anyway, so let's create some more variable references here. We'll do private transform level part, part start. So this will be like our starting part, which we're gonna use to get the endpoint off of that. Do another serialized field, another private. I'll do a list of transforms, and this will be our level part list, something like that. And then we'll have to get reference to our player. So we'll do private player, right? And then we need to calculate the last known end position while the parts are being populated, right? While the parts are being instantiated in the scene, right? So we'll do a private vector 3 last end position, something like that, right? And then we'll do an awake method and start setting some of this stuff up. So the last end position is going to be level part start. So we can do find, and we can do end point, right? And that's going to be the position. Right when we start the game, we can instantiate like a series of parts just to get the ball rolling here. We'll do like int spawn level parts or something, and we'll do like 5 of them, and then we'll do a little for loop. So int I equals 0, I is less than start spawn level parts. Yep, I plus, right? Basic for loop. Well, first of all, let's create a function that we can reuse. So we'll do like private void spawn level part, right? We'll choose a random level part from the level parts list. So we'll do transform chosen level part, I don't know, equals level parts list, and we'll just choose a random one. So we'll do like random dot range 0 to the end of the list. So level parts list parts list dot count. Whoa, man, I cannot type today. Dot count. Okay. So that'll be like our just randomly chosen level part. So it might be a broken road, it might be a straight flat road, you know, it's just just be completely random. So we'll do transform last level part transform or something equals, and then we'll have to, let's create a separate, we'll create a separate function for this. So we'll do like we'll create a function that returns a transform. So do private transform. So it's going to return a transform, and we'll do like a spawn. So we'll just call this one spawn level part transform or something, right? Let's take some input. So this will be like the transform of the level part, right? Level part, and the vector 3, the spawn position of the part, right? So the spawn position. And basically what this is going to do is going to go transform level part transform. Yep. It goes instantiate, so we'll instantiate an actual level part. this spawn position, and for the rotation, we'll just do quaternion identity, and then we're going to return that level part transform. Right? Cool. So then that transform will be what we do here. So we'll spawn level part transform, and we'll pass in our chosen level part and the last end position. Right? And then we'll set manually the last end position equal to that last level part transform dot find endpoint dot position. Cool. And so on our awake method, what we'll do is we'll just do spawn level part 5 times. Basically we'll loop over this, start spawn level parts is just 5. We can set that to be whatever we want. We can even make this a public variable so we can set it in the inspector, but I think for now we'll just keep it scoped in the awake method. And then here let's do an update loop. So in an update method, so if the player is still valid, if it's not null or anything else like that, we need to check the distance between the player currently and the last known end position. So we'll do if vector3 dot distance, that's right, distance between the player dot I need to get the position. You know what? Let's create a new function in the player. We'll create a little helper function down here. We'll just do public vector3. So this will return a vector3, and this will just be called get position. So this will get the position on the character and just return it to us. This will be a nice little helper function. So basically, if the player isn't dead, so we'll handle this later, but basically we have to do check if player is dead first, right? So if the player is dead, obviously we don't want to be returning a position. We just want to return null, right? But basically, for now, we'll just return the transform, but we'll handle the whole death thing in a minute. So, so get position will just return the transform of the player. That's just going to be a little easier for us to call this. So we'll do player.get position, the player's current position, and then the last end position, right? And then we want to make sure that that is less than the distance, right? So if that is true, then we want to spawn a level part. Right. So that'll update continuously. Let's save that and give it a shot. So we'll stick our level generator under our managers game object. So we'll click managers up here and toss in our level generator. And then our level spawn start, I think we'll just, what I'll do is I'll click this little lock button, and then I'll just grab, I think it's this segment. Yeah, okay, so it's this segment, and I'll put that here. And then our level parts list, we want to add all of our prefabs. So we'll go under prefabs, roads, and I'll just grab all of these guys and stick them in here. That's gonna be our parts list, right? And then we'll grab our player, and I'll just stick them in here, and we're ready to check it out. Okay, so now that we have our level generator set up, let's give it a shot. So hit play in Unity, and we'll hit play. Cool. All right, looks like our level generator is properly generating the random segments. As we go down here, we can see it's generating quite a bit. So we could probably dial that back a little bit. But one thing is when we hit the jump button, it's not jumping. So we got to fix that real quick. So I think what's going on here is, yeah, I did not assign the prefabs to be on the ground layer. So let's do that. Yes, change children. Same thing here. Ground, change children. And we'll do that with our prefabs as well. Now, I think what I'm also going to do is increase the scale a little bit of the roads, because right now they look kind of small compared to the character. And what I'd like to do is maybe pull the camera back a little bit further away from the character. So I think what we'll do is we'll try to scale this up, maybe something like 1.25. Yeah, that looks like maybe a little better. So let's do that. 1.25 on these guys. I'll just grab this and pull it back a little bit. That's good. And then we'll have to do that same thing with our prefabs as well. Okay, I adjusted the scale of all my prefabs, so I'm gonna go ahead and hit save my scene here, and let's try it out. Just make sure we can jump, make sure all of the segments are populating correctly. Sweet. And then if I fall through one of the cracks, I should die, even though... So I made a box collider 2D over the entire thing. So what we have to do is we have to adjust these to where it actually goes in the gap, like this. So what I'll do is add another box collider 2D to the other side. And I believe it's that one, yep. So let's do this real quick. Something like that. Give that a shot. And we'll hit play. Boom. Oh no, we fall and we die. Okay. Now let's handle the logic where the player has to die when he falls through a crack, right? So what we're going to do is pop open our player script, and maybe I'll just stick the new bool in here, maybe under scene refs or something. We'll do public bool is dead equals false. So he's not going to be dead when the scene starts. And then in our fixed update, what we'll do is add a conditional check here. So if is dead is ever true, then we're going to destroy immediate the rigid body 2D, right? Because we don't want to have physics applied to that anymore, and then we'll just return out of this, right? So the reason why we put this at the beginning of the fixed update loop is that anytime that happens, none of the other logic happens. But we do need to trigger that to actually occur, right? So under a handle movement call to the function here, we'll just do another one. So if he's not is dead, we'll use our get position function that we made earlier, and we get position dot y is less than like -4f or something. If he's like less than -4 away from the 0 line where he's at currently, then we got to kill him, right? So we'll create a new function called die. Maybe we'll stick that down here or something. So we'll do public void die. We'll do is dead is true. And then we'll do some other stuff on here. We'll do the rigid body 2D dot velocity is vector 3.0. So we'll just zero out the velocity. We're going to destroy that anyway, but you know what? Let's just destroy the entire game object, right? And that's pretty much it for here. But what we can do is, like, for the future, we can create something in the game manager, like call like a game over function from game manager. So we'll handle that later. But basically what that's going to do is like show a little pop-up or something that like has your, like, saying that you died and has your high score or something, and then a little like restart button, so it'll restart the level. But back up here, so I'll grab this die function and we'll put that here. So we'll call that function if he's ever still alive, but his position is lower. So basically meaning if he falls through a crack, right? So we'll add a little comment here. If player falls through a crack, he is dead. Okay. Cool. So we'll hit save on that and go back to Unity and recompile this and see what this looks like. And now this should allow our the logic that's in our camera follow script. Basically, it'll switch this here. Let me just get rid of that note. So if the target exists and he hasn't fallen behind the camera, then we'll just continuously follow the player, right? Otherwise, if the target does not exist, meaning that we destroyed him, then the camera's just going to continue going straight. See what this looks like, right? Cool. And we'll hit play, we'll jump around a little bit. Oh, we fell through a crack. All right, cool. Perfect. So we can see that our character is being removed from our hierarchy here, and the camera just continuously moves forward until you restart the game. So next up, we're going to do is create a new panel in our UI to show like a pop-up that, you know, whenever you do die, gives you the option to restart the game. UI panel, and we'll just call this like game over panel. Right? And we'll hit F to focus up on that, and it's taking up the entire screen, which is probably fine. What we'll do is like maybe we'll just like make this kind of dark, and you know, adjust the opacity a little bit or something, and then we'll create like a new panel inside of this UI. What we can do is just like duplicate this, and we can put this as a child, and then we'll color this like white or something, and increase the opacity, and this will just be like a little panel like this. We'll just call this panel, and as a child of this panel game object, what we'll do is we'll create a button, or maybe, you know, first we'll create some text and just say like "you died" text, right? And then we'll increase this, and we'll drag our little corner points here to be like at the top, something like this. We'll just like increase this, and then we'll add a little bit of a buffer, and we'll make our text black, increase the size, and then we can like align this to the center or something like that, and be like "you died," right? And then under our panel, we can go ahead and add a UI button, Text Mesh Pro button, and do like button restart. Anchor this to the bottom of the screen and kind of increase the size of this like that. Something like this. And we'll maybe color it blue. And then the button text, we'll color that white. Increase the font size. And just say restart. Or maybe how about just play again. So we can add some more stuff to that later, like you know, your top score or something like that. But this will be good enough for right now. So what we'll do is, you know, we'll just like grab this game object and we can just hide it for now. And we'll make some adjustments to our game manager. So we'll pop open our game manager script here, game manager. And under UI refs, what we'll do is we'll add a new public game object, which is going to be our restart panel. We'll just call this game over panel, right? And then we'll create a new function. It says public void game over. And in this game over panel, we can do all kinds of stuff. Like we can like calc, top, score, save stats, stuff like that. And then eventually what we're going to want to just do is do the game over panel dot set active true. Right. And then what we could do is that jump button, we'll also hide that. So we can just grab this here, jump button dot game object dot set active false. So we'll paste that guy in there. So whenever game over is called, that jump button is going to be hidden, and our game over panel will be shown, right? We can even do that last if you want. That's pretty much it for now. So what we'll do is we'll just hit save on this, and then we're going to have to create a new function to restart the game. So under managers, our game object, our game over panel, we'll just grab this guy and toss that in there. Cool. And then back in our game manager, create a new function, public void restart game scene. Probably have to import the scene management. Yeah, Unity Engine.scene management. So we'll import that. So make sure you have this at the top of your screen. So we'll do scene, scene equals scene manager. That's part of the scene management namespace. Dot get active scene, and then we can do scene dot load scene, scene dot name. Okay, so that restart button will just reload the scene fully. We'll hit save on that. In our game over panel, on a restart button, we'll do is we'll grab a reference to our managers, and in our game manager, we'll do that restart game. Cool. And then we'll go ahead and hide this. We'll hit save and test it out. So now if we die, we should see that restart panel show up. Oh no, I died. Okay, so nothing happened. So we got a bug. Let's try to fix it. Okay, so let's fix the bug where the game over panel is not being shown. So let's go under our game manager. We have this game over function. We need to call that from the player when he dies, right? So we need a reference to our game manager. So I'll stick that right here. Serialized field, game manager. We'll just call this game manager. And we'll reference that in the inspector, and then we'll come back down here. So when die is called right here, yeah, we have our function. Well, we have a note here to call that function. So let's do that now. Game manager dot game over. Okay, we'll hit save on that, recompile, and we'll give this a shot here. We need to reference our game manager in our player script here. So we'll scroll down on our player and we'll drag in our managers into the game manager slot there and hit save. And we'll hit play and check it out. Cool. We can do some cool tricks. Dodge some gaps. Oh, we fall and we died. Okay, cool. Perfect. So now if we hit play again, we should restart the scene. Awesome. Oh, we got to fix that. That's a little bit of a bug, huh? Okay, let's go ahead and fix that bug where the character sort of tips over when he trips over something. You know, specifically when those little gaps occur and he's not able to fall directly through it because he's moving a little too fast. If he ever like tips over, we can kill him, or we can just stop him from tipping over like at all, right? So one way we can go about doing that is we can write it in our player script. So this is just one option. So we could calculate the angle in our fixed update loop, right? We can calculate the angle of the character. So like for instance, we could just, I'm just going to show you this. We can do like float angle equals vector 2 dot angle, and we can calculate it from the player's transform dot up vector and the world up. So vector 2 dot up, right? And then we can say if angle is greater than, I don't know, like 60 degrees or something like that, then we call that die function, right? And then that's going to kill the player. So that's like one way of handling this. We can just, I'm just gonna like, we can test this out. What's going to happen here is that this is not going to lock the player in the it's not going to lock the player's up axis directly up all the time. So we're going to have some like interesting bugs, right? And you probably have already noticed this, but sometimes like when we jump, it you know, it like applies the force. Oops. It applies the force and like it'll cause the player to sort of rotate a little bit like that. Okay, so yeah, that's a perfect example. I'm glad that happened. So that's something that I want to account for. It looks like it is working though, like our little script modification. So yeah, okay, so if I tip over, then I die, right? Now, another way we can solve this just to make the game a little bit easier to play, right, is we can just get rid of this. I'll just comment that out for now. We'll save that. We'll go back here, and then we'll modify the actual character's rigid body component. So if I drop down the character, well, it's actually on the character itself. So click on the character, we'll scroll down to the rigid body, and under constraints, we'll freeze the rotation in Z. So that'll keep the player from rotating like this, right? So it'll always be facing upward. So let's play that again. And let's see what happens when I trip over one of those small little openings. Okay, so I fall right through it. Okay, that's perfect, right? So like if you don't jump in time, you fall right through it. And okay, cool. So with that set up, the next component of the game I want to work on is the grind rail functionality, right? So in Night Skate, it's a big part of the game where you're jumping around and stuff while you're skating. You collect points, but also if you grind on rails, then you collect points too. And they have a really awesome mechanic where like you can slam down on rails, but also you can like skate past the rails if you want. So I want to incorporate that. Also, we can do like a screen shake and some particle effects and stuff like when you're grinding and stuff. For now, let's just get started setting up the grind rails, and we'll get them incorporated into our prefabs here. So first up, what we need to do is go into our sprites folder, into props. I have a grind rail asset created here, so I'll just drag one of these into my scene, and we'll set the order and layer to something like 3. So anyway, our grind rail is a little small, so we'll lock the scale, and we'll set this up like a little bit bigger. Something like that should be pretty cool. So maybe like 2. What we need to do now is we have to create a grind rail like trigger, right? So what we're going to do is we're going to create an empty game object, create empty, and we're going to call this grind trigger. So whenever the player jumps on top of the trigger, it's going to trigger an event, right? So what we have to do is we'll create a box collider 2D, and this is going to be set as a trigger, and we'll have to scale this up a little bit, and then what we'll do is just put this at an angle. So we'll adjust the rotation on the Z here, so something like that should do it, and then we'll just drag this guy up, so it's just going to be like right on top of the rail, something like that. Right, so we'll make this big enough to where he doesn't automatically hit it, he'll just have to jump onto it. So something like that should be fine. And then the second component we're going to add to this grind rail as a child game object is like an actual collider itself, right? So like that's just going to be the trigger that triggers a grind rail, like the sort of grind mechanic. And then the other one is going to be an actual collider. So we'll just call this collider. And in the collider, we're going to add another box collider 2D. This one's just going to be a regular box collider. What I'll do is I'll grab this transform, I'll copy this component, and I'll just paste this here, paste component values, and then we'll scale this up to be about the size of the rail again. And this time this is going to go like right beneath the rail. So basically we're just going to like capture the actual rail. And this is what the player is actually going to collide with. In order to get the functionality where the player can like optionally like ride right past the rail rather than like immediately grinding on it, or because like if we just leave this as is right now, if he tries to skate past it without jumping on it, he's going to slam right into it, right? So we want to be able to only affect it if the user jumps and lands on top of the rail. So the way we can do that is by using an effector. All right, so we can click on this use by effector, and we don't have an effector on this component yet, so we'll do a platform effector 2D, and that error goes away. This is going to allow us to basically like go right past the rail without jumping on it. So what we'll do is let's grab our rail and we'll just like put it over here, and we'll just like test it out real quick, see if this actually does anything cool. I should be able to cruise right past the rail without hitting it. Yeah, perfect. Okay, I'll die, I'll play again. And I should be able to, yeah, see, perfect. So I'm able to jump onto it. So with that set up, what we have to do is we have to create a new script to place on this grind trigger, right? So this is going to basically like trigger the grind mechanic to start, right? So we'll go into our scripts folder. I'll right click in here, create new C# script, and we'll just call this grind trigger. Okay, we'll open it up. Let's get rid of the update method. We'll keep the start method because we're going to need that. Okay, so what we'll do is we'll create a reference to our player. So we'll do private player, call it player, and then we'll do private boolean is triggered. So we'll keep track if it's triggered or not, right? And then on start, we'll get a reference to our player. We'll actually find the player in our scene. Do like a we'll just call this player equals find object of type, do player. So anytime one of these is created in the scene, it's just going to automatically find the player, and then is triggered is false. So we'll false that out. And then we'll do on trigger enter 2D, which is a built-in Unity function in model behavior. we'll compare the tag of whatever hit this trigger. So if other.gameObject.tag is player. Another way you can do that is like other, I think it's gameObject.compare tag, but this is fine. Is player and is triggered is false. Or we could just do like, do something like this. Is triggered, right? We'll do another check to make sure that the player is actually currently grounded, right? So we're gonna have to modify our player in order to get this system to work a little bit, but that's okay. So we'll do if player is grounded, if he's not currently grounded, how about that? So if he's not currently grounded, player dot, and we'll do a new function like called like start grinding. So we'll have to create that in our player. And then we'll do is triggered is true. So we can't double, maybe we can like do something where we can't double grind on it. Or we could do something like this where we'll do on trigger exit 2D, yeah. So if we'll do the similar thing, other.gameObject.tag is player, right? Because there might be like other stuff like the cars and stuff eventually. And then we'll create a new one like called end grind. How about that? And then is triggered is false. We'll just like false that out, right? So we have to create those two new functions, start grinding and end grind. So back in our player script, let's create those two new functions. But first, what I'm gonna do is up here. Maybe we'll put this like here. We'll do public bool is grinding. Let's just create our two new functions. We'll put them right here. So like public void. What did I call it? Start grinding? Yeah. Start grinding. So like is grinding is true, right? And then we'll do animator dot set bool is grinding, and we'll set that to true. And I guess before we do that, we'll actually set up animator.setFloat. And I think it was grind type. And you can always go back in your Animator Controller to like copy paste these strings because you need to be precise about how you type these because otherwise you won't find it. So we'll grind type, and then we'll just choose a random one, sort of like we did with the jump animations. Dot range between 2. We have 2 grind animations, so we'll do 2. And then we'll create our other function, public void. What was it? End grind? Yeah, end grind. We'll just copy that. Public void end grind. And end grind is basically you're just going to set this is grinding is false, right? And then we'll do animator set is grinding to false. That'll set us back to idle, or if we jump off the rail, it's just going to send us right back to jump because we set that up already. Cool. So if I save that, I save this file too. So we'll have to put this grind trigger on the actual grind rail component. So we'll do that now. Okay, so grind trigger, I think we'll stick that right on here. Yeah, cool. So let's give it a shot. So I'll hit save on that, and then we'll try to do some grinds. So I jump. Cool, yeah, so that works. Sweet, so I die, I'll just try that again. Sweet, okay, so there's a little bit of a lag. So I think what we'll do is in our animator, between jump and grind, okay, I'll just get rid of this has exit time, so it'll let go directly into the grind animation. And then similarly, I guess, we'll remove the has exit time too here. Because basically I want to like jump, and then while he's doing the jump animation, immediately go into the grind animation, and then when you jump off the rail, it goes into the jump animation again. So now that we have this grind rail set up and it's working correctly, what we can do is create a prefab from it. So maybe I'll just create like a separate folder here in our prefabs folder and just call this props. We'll toss in our grind rail here. Cool. And what I'll do is I'll just delete this instance of the prefab from the scene. And in our roads prefab, I think what we'll do is we'll copy a couple of these roads. I'll call this, so this is road flat 02. And then we'll call this width rail. We'll open this one up. And we'll stick our prefab in here like that. Put it wherever you want. Sweet. Maybe we'll do one more. Yeah, maybe this one. One with rail. Cool. And then I'll grab my roads. Sorry, my props. Grind rail and stick this in here. And maybe we'll make this one a little smaller. So let's give this a shot. So what I'll do is back in my managers, in my level generator, I already have all of these in here. So what I'll do is I'll just lock this. I'll grab my other roads we just created with the rails. Adjust this so we can see just the names. I'll grab the rails and we'll just toss these in here in our parts list. So they'll start generating too. Sweet. Let's hit save on that. And when we play the game, we should start seeing those rails generated. So hit play. There we go. I could probably adjust that a little bit. There's some stuff we gotta make a couple adjustments because it doesn't seem like it's grinding all the time and I can't jump off of it. So there's a couple things we gotta fix here. Let's make a couple adjustments to our Animator Controller here. So from jump to grind, we want to basically just shrink this time up. So we'll just grab that and push it all the way down. So it goes directly from jump directly to grind, right? And then from idle to grind, we want to shrink that one up too. So we'll just have this be at 0 seconds. So it just goes directly from idle to grind, right? And then the rest of these, from idle to jump, maybe we can shrink this down a little bit so it's a little faster. So it just immediately kind of goes into that jump animation within half a second or whatever. Sweet, so let's try that out. One thing we do have to fix in our player script real quick though, adjust our check grounded function, wherever that's at. Check grounded. Okay, so we're gonna have to account for the is grinding boolean as well here. So underneath colliders, what we'll do is check if is grinding. Then we'll just set is grounded to true immediately, right? Otherwise, we want to set is grounded equal to if there's any colliders, right? Because we know the collider exists on the grind rail, so that's the thing that we're actually grinding against, right? Let's give this a test now that we adjust the Animator Controller and stuff. So hit play. Yeah, that works a lot better. Okay, cool. So I'm able to jump off the rails now. Yep, perfect. So I think next up, we'll probably start working on our points system just to get something rolling on that. And then we'll do some more background art and stuff like that. Okay, let's start setting up our points system. So under our canvas, let's just go ahead and click on our canvas and type F to zoom out to the entire canvas. I think up here in the top left or right corner, wherever you want to put it, we'll put in our little points counter, right? So we'll do text mesh pro, and we'll just call it points text or something. And we'll toss that up in the top left, and we'll anchor that to the top left, and we'll increase the size a little bit. And we'll just kind of make this pretty big, right? And we'll just do 0, 0, 0, 0, something like that for now, right? And we can make it bold or something, right? And maybe up there we can put a panel to where because it might get blocked by the UI, so maybe we'll do that. We'll just create a little panel for it. So do panel, points, panel. Maybe we'll put some other stuff up here too. And what we can do is just drag this up here, and we can anchor that to the top like that. The points text is a parent of that, and we can even anchor this to the side of it like that. So it'll kind of anyway, with that set up, we'll go into our game manager and start setting up some other stuff here. So in our game manager, Maybe here, we'll do a header. We could do like points. Here we can do a reference to do serialized field, private TMP text, and we'll do like points text, right? And then we'll also create a private float points. Okay, so whenever we're playing the game and we want to add points to the player, we're going to increment this points float value here, right? So we need a function to add points. So we'll do public void add points, right? And this is going to take a float parameter for like points to add. So basically, like, we're going to increment that points value. So points plus equals points to add, and then we're also going to update that points text object, right? So that points, was it points text dot text equals points to string. Cool. So now anytime we call this function and we pass in the amount of points we want to add, the UI will update, right? So let's go ahead and save that, and before we start calling that function, let's just connect our points text object to our game manager, so we can start seeing this happening, right? So under our game manager and our points text, we'll just grab this points text and put that in there. We can even hide this entire panel until you hit the play button, so maybe we'll do that real quick. So on the start button, what we can do is, like, we can even create a separate private game object points panel, right? And then on awake, on awake we could do points panel dot set active, false, and then grab that, and when you hit the start button, then it sets it to true, right? Cool. So that way it'll just be like hidden right when you start the game, and then right when you hit play, then the points panel will appear and it'll start accumulating points. And so now we have some decisions to make about how we want to accumulate the points. So in our player game object, we know that we already have a reference to our game manager here. And what we can do is, let's say for instance, whenever he jumps, he gets some points, right? Whenever he starts grinding, maybe he'll get some points or something like that. So maybe those two things is like how we start accumulating points. So we can start there. So the simplest way to do this, so like when we call jump, maybe when you successfully land, we can call that, maybe we can just do like add points. Add some points, right? We could do game manager dot add points, and maybe when you jump and you land, maybe you get 10 points, right? And then we can do the same thing here. When you start grinding, maybe when you end the grind, meaning that you successfully grinded and then you didn't fall into a hole or something, we can maybe like add 20 points or something like that, right? And then we can also, this is like just the simplest way of doing this, right? Like another way we can do this, we can like calculate the amount of points to add to the player, like depending on how long he's in the air for jump and like how long he's on the grind rail. And then maybe we can even do combo points. So like if you're if you like jump and then do a trick and then land on a grind rail, maybe that like doubles the points or something. There's all these different ways that you can build onto this, but for now we'll just keep it simple. So if we hit save on this and we recompile the script here, we can probably play it and see what happens here. Okay, so oh, I forgot to make a reference to our panel here, so let's go ahead and do that. So in our game manager, we have to get our points panel, and we'll stick that in here. I'll hit save. Cool. You see our points panel disappears and we're ready to play. So once we hit play, the points panel appears, and when we jump, we successfully land, we get some points, right? So there's a way we can store. There's a bunch of different ways actually. We can store the points. So like every time you play, maybe you can see like your total, like your top score, right? So let's do that. So we'll just like grab this guy and we'll put this over here, and we'll duplicate it, and we can put like top score, right? top score. And maybe I'll stick this over here on the right side of the screen. I'll justify the text to the right, and maybe we'll add in like a little text that says like top score or something like that, right? So what we can do is, instead of doing like this, we can like shrink this down a little bit and just duplicate that, put it above here, and just call this like top score text, right? Put this up here like this, and we'll just shrink this up a little bit. This doesn't have to be bold. Just call this top score, and then maybe we'll just like make this like, I don't know, green. So now we'll make a reference to this top score. Let's say top score text, right? And we'll call a reference to that in our game manager. So in our game manager where we have points, we'll just duplicate this down, and we'll call this top score text. And so every time you die, and we want to grab the points, we want to save it somewhere to where when we refresh the scene, it always like just shows that. Instead of this, we'll do like private float top score, right? So on game over, we'll say if, so we'll do like a little calculation, calc top score, and save, right? So we'll say like if points is greater than top score, then top score equals points, right? So we'll set the current number of points equal to the top score, right? So that's your new top score if you beat your old one, right? And then what we can do is save the top score to player prefs, right? So we can do player prefs dot set float. We have to name the float something, so we'll say top score, and we could just do top score, right? And so that's only going to save your top score if you beat your previous top score, right? So, but on maybe on start, what we can do is get that float value and set that to be your top score, so it'll always show it. So what we can do is say top score equals player prefs dot has key. So we'll check if it has the key top score, and then we'll do a little conditional statement here. So if it has a top score, then we want to set it to player prefs dot get float top score. Otherwise, it's just going to be 0, right? And then what we want to do is we want to render that in the UI. So we want to say top score text dot text equals top score dot toString. And here I'll just put a note here that says get current top score. So once we get the top score in the start method, if it actually exists, then we'll set top score equal to the top score in player prefs. Right. So player prefs is a cool way to store stuff. So whenever you close down the game, then you restart the game, it'll always refresh that top score float value. Let's give that a shot and see if that works. We might have to render the same thing here. We might as well do that. So we can even just do that real quick. Grab this and we'll stick this in here. Right. Okay, and then we'll go ahead and hit play. Oh, I forgot to reference it. Give me 1 second. Keep doing that. All right, so in our game manager, we got to grab our top score text. Put that in here. We'll hit play. We'll try to get some points here. And then if I die, oops. So we see our current score, 350, and our top score is 350, right? So we play again, and we hit play. Our top score is going to always be 350. And anytime we close down the game, that 350 is always going to be my top score. If you ever need to reset that, I think you can go to edit, clear all player prefs, and that'll clear out your player prefs. So that'll clear out, your top score value. Okay, so now I want to work on 2 separate things. So one is a coin generator, which I want to be able to spawn coins for the little skateboarder dude to collect. And if he jumps and he collects one of the coins, then he gets like 100 bonus points, right? And then another thing to make the game slightly more difficult is I want to generate cars that are like coming at him on the street, right? So you have to like be able to jump over the cars. Okay, so back in our assets folder, we'll pop into our scripts folder. We'll right click and create a new C# script called coin. And what we'll do is we'll double click, open up our coin script. Okay. And then what I'm going to do is I know that I'm going to need a reference to our game manager, private game manager. So because whenever the player makes contact with one of these coins, we're going to destroy the coin and then also call that add points function, right? Add points right here, right? So in our coin, we need the game manager. And then on awake, we can get a reference to the game manager. So we can do game manager equals find object of type and do game manager, right? And then I'm going to put a collider 2D, similar to how we did it on the grind trigger. So on trigger enter 2D. So we're going to do that the same thing here. So on trigger enter 2D. And when the player makes contact with this object, so I'll say if other.gameObject.tag equals player. If the player hits this game object, we want to do a couple things, right? One, we want to do game manager dot add points, right? We'll do 100 bonus points or something, and then we want to destroy the game object, right? And we can also do like other cool stuff here, like we can play a sound, we can make a little particle effect appear or something, like, you know, like a little particle system, like a burst or something, all kinds of cool stuff. But this is just like the very basic version of what this potentially could be. So this is just our coin. So we'll go ahead and save this. We'll recompile this and we'll start creating our coin prefab. And now we have to think about, what do we want this little PizzaSkater to collect? It can't just be coins, right? So I'm thinking, I don't know, he's a piece of pizza. Maybe he collects little pieces of cheese or something, right? I don't know. So let's, so I created a little cheese blob. Let's see, in our sprites folder and props, created this little cheese. So I figured this would be a good little coin to collect, right? So maybe we'll, you know, maybe scale that down a little bit. Okay, so we have this set up, and what I'm going to do is I'm going to add a box collider 2D component, and this is going to be a trigger, and we'll just leave that the size that it is because it looks pretty good. And then what we'll do is we'll go back into our scripts folder, and the coin script that we created earlier, I'm just going to drag and drop this on our coin cheese prefab, right? And we can even, let's go ahead and just call this coin, because the coin is a piece of cheese, but you know, like it could be anything. So, you know, we can just leave this as a generic coin, and then if we wanted to change these out later, we could always swap out the sprite, right? So in the actual coin script, we could get a reference to this sprite renderer and then change out the sprite if we wanted to. We can like randomize, you know, have them be like, I don't know, you can make them like tomatoes or like pepperoni or something. I don't know, whatever little pieces of pizza want to eat, you know? I don't know. So, okay, so with that set up, that's pretty much all we need for the prefab. So we'll go into our, maybe our props folder or something, and we'll grab this coin cheese and we'll just drop this in here. And we can go ahead and get rid of that from our level. All right, cool. So on our manager's game object, we want to create a new script, but I'll just, I'll do it in this scripts folder here, and we'll do create C# script, and we'll call this coin generator. We'll pop that open. And I guess we'll get rid of the update method. We're not going to need that. I'll get rid of this comment. And we'll start doing getting some references. So we'll do serialized field, and we'll do private coin, and we'll call this coin prefab, right? And we'll do serialized field, and we'll get a private reference to our player. Let's call this player, because we're gonna get the reference to the player to call that get position function that we made on the player. That's right here, and that will allow us to figure out the exact position of where the player is in the level whenever we want to call this function to generate a coin, right? Do another serialized field, a private. We'll do a float value, basically like a minimum y, and we'll set that as a default, like maybe like 1.5 f, just so it's like a little bit above the road, right? And then we'll do another one, private float max y, right, equals maybe like 5 f. So those are the min y and max y is like the sort of like a range above the road that the coins can spawn in. I think what we'll do is we'll create another function down here called private void generate coin, right? And we'll call that in the start method, but we're going to invoke it repeating. So what we're going to do is, for the first thing we're going to do is get a vector 3, get the player position, equals player dot get position, that function that we created, right? We'll generate a random y value for where we're going to put the coin, right? So we'll do like a float random y equals random dot range, and we'll do minimum y, min y, and max y. Right. Cool, so that'll give us a random number between 1.5 and 5, like we set up here, right, for these values. And then what we can do is vector 3 coin position equals new vector 3. We'll build a new vector 3 from the player position dot x plus 10f. Maybe we'll have to tweak that value, so we can also set up a separate value for like how far away the coin should spawn, but I think 10f is fine for now. And then we want to put in our y value, so that random y that we created earlier, and then the player position dot z. So that'll create our coin position, and we just have to instantiate it there. So we'll instantiate our coin prefab at the coin position, and then we'll do for the rotation just quaternion identity. Here in our start value, we'll just do invoke repeating, and we'll call the generate coin function. We have to do it by string, so generate coin, right? And then we'll do it once every like 2 seconds or something like that. And then the repeat rate, like how often this is going to repeat, we can do like a random dot range, and we'll do it once every like between once every 2 seconds and once every like 20 seconds or something. And these values here can definitely be variables that we can expose in the editor and, you know, tweak and stuff like that. But just for now, you know, we'll just like put this in here hard coded. After about 2 seconds of gameplay, this will start. So I'll start generating these coins, right? So what I'm going to do is I'm going to save this. And then on our manager's game object, we're going to put on our coin generator. So I'll do this, put this right here. And then we have to put in our player right here. And then our coin prefab, we'll just lock this real quick. And then our coin prefab is in props coin. So we'll just toss that coin right here, right? And I think that's all we need. So I'll go ahead and hit save. And I'll unlock that. And let's give it a shot. It should generate, it should give us 100 points every time we hit one of those little pieces of cheese, right? Yeah, okay, cool, so it worked. We got one. It's still a little too easy to play, and I think we're blocking too many of the holes where you can fall down, so I might remove one of the prefabs that has the grind rail, just because like there's not that many opportunities for you to fall and die. So it has to be a little bit more difficult. One thing we can look at doing is like making the level progressively more difficult, where like there's like smaller and smaller like little platforms and there's more gaps. But I think for now we'll kind of like, we'll make some tweaks and stuff. Okay, so now let's make the game substantially more difficult, right? So now what we're gonna do is we're gonna work on our car generator. That's gonna generate all of these little car prefabs here, right? So the idea is we're going to create a prefab with one of the cars, and we're going to be able to swap out the different car sprites. We're going to create one prefab of the car, and it's really tiny. So what we're going to do is scale this up a little bit. Something like that. Let's see how this looks. Yeah, that's pretty good. That way player can jump over these. This is going to be crazy. All right. So first thing I'm going to do is I'm going to add a boss collider 2D. And this is going to be a trigger, right? We do need to create a script that's going to push the car in the opposite direction of the player. What we can do is add a rigid body 2D to this car. So we have that set up. We do need to create a new script for the car to actually move them. And we have this box collider, which is a trigger. So anytime the player hits that box collider, he's going to die, right? So if we play the game right now, nothing's going to happen. But this should fall on the ground and... Okay, cool. So it does not hit the ground yet. So if we uncheck this, and what I'm going to do is I'm going to put the sorting layer, I think we have the character on 10. So maybe we'll make the cars... We want them to be above the car, so you know what we'll do is make these like 11 or something like that. If I uncheck the trigger, so instead of trigger enter, maybe we'll just do like on collision. Yeah, okay, cool. So that's what we're gonna do. In the scripts, we'll just create a new script and we'll call this car. And I'll double click to open my script for the car up. And basically what we're going to do is very similar to the coin, but this time we want to get the reference to the player instead of the game manager, because the game manager is already called from our player. So we're just going to call this die function if anything ever hits this car, right? So we're going to get a reference to our player. So we'll do private player, and then in our awake method, what we can do is just do player equals find object of type, and we'll do player up, and then basically we can use the on collision enter 2D. So anytime anything collides with this, we're going to test if other.gameObject.tag equals player, right? We've done this a few times already. We're going to do some other logic here. So we're going to need a reference to the private rigid body 2D, and first thing we're going to want to do is say rigid body 2D. We're going to destroy this, right? Stop that from doing anything. So destroy immediate rigid body 2D. Right, so we're going to destroy the rigid body, and then what we want to do is call that, because basically when the car hits the player, we want the car to stop moving, right? And so we're going to set up the movement in a second, but I just wanted to put this in here for now, right? So then we're going to call player.die. Right. And then what we need to do is do a fixed update. And then in our fixed update, we're going to move the car similarly to how we move the player. So I'm going to go to the player, and in my handle movement function, I'm just going to grab all this, and I'm going to paste it in here. And of course the speed is going to be way too fast. So like we'll put that down to like 2F or something. That might still be way too fast. And then instead of going in the positive direction, X, right, we're going to go in the negative direction. So it'll be basically just negative 2F, right? So that'll make the car go from right to left. No, you know what we'll do is we'll actually get a reference to it here. Rigid body 2D equals get component rigid body 2D. Okay, so we will compile that. And then if we put the car script on our car prefab, what we'll do is we'll just toss it in right here. And then once we hit play, we'll test this out. The player should die when he hits the car. Yep, I died. Okay, cool. So boom, died. So let's see, we're getting in destroying components immediately is not permitted during physics. Okay, you must use destroy instead. Okay, so instead of using destroy immediate, we'll just use destroy. Destroy. Yeah. Cool. So hit save on that. And the cars are moving a little slow, so maybe we can speed them up a little bit. Maybe we can incrementally speed them up. So like maybe, or like randomize the speed that they're going in. Yeah, okay, cool. Okay, the rigid body was destroyed, but you're still trying to access it. Okay, so we have a bug here. Okay, so we'll go back to our car script, and I think what we'll do is instead of destroying the rigid body, we could just do, so if it ever hits the car just keeps going, and the camera keeps moving and stuff, and then like, you know, that's it. So clear this stuff out. I'm gonna grab my car and just push it back here a little bit more, so we can give this another test. Cool, then I'll play, boom, died. So the car keeps moving, we have no errors, sweet. And then the car will just probably fall off the edge of the cliff there, cool. All right, sounds good. Okay, so what we're gonna do is we're going to make this car a prefab so we can instantiate them. So in my prefabs folder, under props, I'm gonna grab my car, and I'll just rename this car. Cool. And then I'm going to stick that car in here. Before I do this, actually, let's go back into our car script and make a reference to some sprites, right? So we'll like, what we can do is make a, maybe like a list of sprites or something. So we could like do serialized field, list of sprites, car sprites, right? On awake, we can set one of the sprites. What we have to do here is we'll have to get a reference to our sprite renderer. So we can do private sprite renderer, sprite renderer. And then here we can do sprite renderer equals get component, being that's the same, it's on the same component here, sprite renderer. And what I'm doing here is the sprite renderer is this guy that's right here, right? Because our car script is still attached to this. So we're just gonna get that component, right? And we wanna get the sprite render.sprite, right? And so the sprite renderer.sprite is going to be equal to car sprites at, like we'll say, random.range, range, wow, I cannot type today, range, between 0 and, let's see, car sprites dot count. Okay. And so it'll just randomly choose one of those car sprites. We'll save that, compile this, and then in our car script that's attached to our car, we'll just reference all of those car sprites. So I'll just lock this here. We'll go into our sprites folder, into props, and then I'll grab all of these cars and I'll stick these in our car sprites list so we can see all of our cars in there now. So Every time one of these is randomly instantiated on the awake method, it's just going to choose a random car sprite and stick it in there. So let's go into prefabs, under props, we'll grab our car and stick it in here. Cool, and then we'll just delete that car, so we don't need that one in our scene. And then we'll create a similar script to our coin generator, pretty much almost identical, just a little bit different. And we'll just call that, you know, the car generator, right? So in scripts, right click, create a new script. We'll call this car generator. Sweet. So we'll open that up and we'll get rid of all this stuff. And basically it's going to be very similar to our coin generator. So instead of, so we can invoke these repeating. A lot of this stuff is going to be the same. We'll still get access to our player. So, you know, what I'll do is I'll just grab this, paste that in here. Before this, we can even do, obviously we'd have to get a serialized field. Private car. This will be the car prefab. Right. And then very similar to what we're doing here, we'll just grab this start method, we'll put that in here, and then we'll have to create a new function called private void generate car. And then we'll just grab this method name and put that in here as the string for the invoke repeating. And then maybe we'll start this after like 5 seconds. And then once maybe every 5 to 20, that seems like it's going to be a lot of cars. We'll see how it works out. Anyway, so in our car generator, very similar to our coin generator, we're going to get the position of the player, and we'll paste that in there. And then instead of spawning them within a random range of minimum Y and minimum X, what we can do is basically just take the same logic here, where we create our new vector, and we can create a new vector here, vector 3, car position equals that new vector 3, and instead of random Y, we'll just say like this is like 1.5f, right? And then the rest of this stuff, yeah, so we just have to, we'll just instantiate it, right? So we'll just copy that, put that right here. So we'll instantiate the car prefab, and at the car position, and that's pretty much it. So we'll save that car generator, compile it, and we'll see how crazy this gets. So in our managers, we'll put in our car generator script, and then we'll have to get our car prefab, which I'll just lock this real quick. We'll go back to prefabs, props, and we'll toss in our car. And we also have to drag in a reference to our player. And if we hit save, let's give this a shot. So hit play. Okay, cool. We got a cheese. Sweet. Oh, we died. So we, you know, so we hit a car. Now we can do all kinds of stuff now. So like, now that the cars are spawning, see, like it's a little bit too difficult now, because one, we have to zoom the camera out a little bit because it's too close. We can like barely see them, and two, they like, yeah, it's like freaking impossible. So let's do that first. Let's like just grab the camera. We'll zoom this out a little bit. So in size, we'll just like increase that a little bit more. Right. And then remember when we made this a Y adjustment, we can like play around with this a little bit. Oops. Yeah, it does. Okay. So in play mode, I think we want the player to sit about there. So 1.95. We got a car coming at us. Oh, we died. Okay. Anyway, one thing we have to adjust is in the car manager. We have to adjust something, but first, right now, I'll just put this in here. So 1.95 is what we want the Y adjustments height to be. So we'll save that, and back in our car generator, we have to open this up again. So we know that back in our game manager, when we hit the start button, we're calling player has started game. So we can just like, now that since we have a reference to our player in our card generator, we can just check and to see if has started game is true before we started instantiating any of these, right? So we have a reference to our player. If player.has started game, if that's false, so we'll do exclamation before that. If has started game, then we'll just return. Right. And so this will still start the card generator, but none of the cars are going to be instantiated until the player has started the game. So let's hit save on that. We'll come back here and recompile and just test to make sure that works. Cool. All right, so I'm not seeing any cars yet, which is good. I'll just give that another second here. We see the cheese generating, but that's okay. Okay, let's hit play. Let's see if a car generates. Yep, okay, cool. Sweet. The cars are still pretty hard to dodge. So what we might want to do is like, yeah, lessen the frequency of them. Or maybe like after, you know, the player has like went through like 10 seconds or something like that of gameplay, then we start generating the cars. Okay, we have one little bug fix to fix with our car script. So if we go into our car script, basically what's happening is that when a car is instantiated, it's just going to keep moving forever. And then, you know, if there's more and more cars, let's say for instance, if somebody is playing your game for like, I don't know, a few minutes or hours or something, going on a total binge of your game, eventually all of those cars, it's going to amount to quite a bit of physics calculations, and we need to get rid of the cars after like a few seconds after they're instantiated. So let's do a couple checks here. So in fixed update, what we're gonna do is like, if the car falls below a certain threshold, similar to how we have our player set up, like we get the position in our fixed update, we get a position, the Y position, if it's less than like some threshold value, like 4, then we'll kill the player, right? So we just need to destroy the car in the same way. So in our fixed update, we go if the transform.position.y is ever less than, let's say, 4 or 5f, something like that. Oh, sorry, negative 5f. Then we're going to destroy the game object, right? And then we can return out of this just so nothing else tries to run after that, right? And then similarly, if in the wake method we have to destroy the car after some time, right? And so what we can do is we can set this destroy method on a delay, which is really helpful. So we can do destroy game object, and then we can specify like a float time. So we can do it after like, I don't know, 5 seconds, right? So after 5 seconds that the car is instantiated, it's just gonna get destroyed, right? So we can hit save on that. And we could do the same thing with our coin, So on awake, we could destroy this after like 5 seconds, just so like these are not like just floating there in the level. We eventually what we're gonna wanna do is like a similar thing with the level generator. You know, so we can just do destroy game object, game object after, you know, 5 seconds or something. That'll give us enough time for the player to find it and to potentially pick up the coin or run into the car, right? But it's not going to, you know, our game doesn't have to continuously render that. And we'll go ahead and hit play. Sweet. All right, cool. So let's watch this car. After about a few seconds, yep, it got deleted. Perfect. Okay, so the next step that we're going to accomplish here is to make our game a little bit prettier. So we're going to add the background image. I have some sprites here in our sprites folder for buildings, and I have a background as well. So what we're going to do is, I've already created some prefabs of these buildings, but first what we're going to do is we'll just add our background sprite, and we're going to put it as a child object of our camera. So let's just go ahead and drag and drop that on the camera. We can position this however we want to, and maybe to scale that down a little bit. The order in layer, we're going to set this to like -10. so pretty far back there. And then we're going to instantiate these buildings as prefabs, and I've already created some prefabs. So I created this new folder in the prefabs folder called buildings, exactly the same way as we created the road segments. Basically all they are is they have a start point and an end point, just like that, right? And that's all they are. So what I'll do is I'll stick one of these in our like level start parts here, and I'll kind of position it like right here, I guess, a little bit further down away from the camera's sort of viewport edge right there. And so that's going to be like the very start point of our level, right? Maybe I'll just like slide it like that or something like that, right? Cool. So I've already created a new script called buildings generator in my scripts folder. So if we open this up, and I basically just copied and pasted the level generator into this and changed a couple things, right? So the building generator script does this effectively the same thing as the level generator. However, it has this parallax speed. So the buildings are going to be instantiated the same way as the roads. However, the buildings are actually going to move slowly, but they're going to move in the opposite direction as the player, right? So basically this on the wake method, we'll get the last end position the same way we did the level generator, right? And then our update method, we'll check to make sure the player exists, and we'll continue moving the buildings here. Let's go back here. I've placed that building generator script on my manager's game object right here, and we need to reference the building start prefab, right? So I put that in there, and I've already added my 3 buildings prefabs in here, and yeah, so I'll go ahead and hit save on that, and we'll play it out and see how it looks. Okay, so you can see my buildings are being generated. I do have to make sure that, okay, so it is working. I'm probably going to just specify a start point. Yeah, so that's looking pretty cool. So we're seeing the buildings move. I don't know how jarring that is. Maybe we'll like adjust the speed a little bit. So I think what I'm going to do, instead of adding in a building prefab at the beginning here, we're just going to get rid of this. But first what I'm going to do is I'm just going to create an empty game object. And I'm just going to call this building spawn start, right? And then we will position this somewhere down here, right? And I'm going to get rid of this building prefab, and then I'll add a little dot or something right there so we can see that. We can even increase the size of these 3D icons a little bit, right? If you want to. So that's going to be like the start of where our buildings are going to start spawning, right? I'll hit save on that. We'll go back to our buildings generator. We'll just call this start point. And then we'll just do start point dot position. Right. So we'll reference that little point that we made, that empty game object that's going to be the start of where we're going to spawn the buildings from. So on a wake, it'll generate 3 buildings, right? And then the update method, we want to make sure that if the player hasn't started the game, that the buildings don't start moving yet, right? Because that would be weird. So if player dot has started game, so if he hasn't started the game yet, right? So we'll put an exclamation point at the beginning of that, then we're just going to return. So we'll hit save on that, and we'll go back to our game. We'll press play and try it out. So we'll hit play, and as soon as the game starts, we should see that the buildings instantiate. Oops, I forgot to reference my start point here. Okay, let's grab our start point and put that in there, and hit save, and then we'll try this again. Cool, perfect. So we can see, first few buildings generated there. That's perfect. And then we'll go ahead and hit play. Cool. So now you can see the parallax effect is happening. It's a little bit fast, so maybe we can adjust the speed of that a little bit. But, basically they're moving in the opposite direction of the player and providing a little bit of parallax to it. Okay, so the last part here is deleting all of the game objects that are way far away from the character that have already been spawned as the character is cruising down the road, right? If the player is playing the game for a couple minutes or even like a whole hour or something, to get really good at the game or whatever, eventually it's just going to be a lot for the game to process. So we need to remove some elements, right? So as the player is cruising down the road, some stuff gets deleted behind him. So I went ahead and created this little deleter box game object here, and I created this deleter box script, right? So I'll show you what this deleter box does, but basically I just created an empty game object and placed it behind my camera, right? Sort of like further behind, so it deletes stuff without affecting what the player is seeing, right? In this deleter box script, basically all this takes is a box size, so we can choose like it's a vector 2, whatever size you want the box to be. You can adjust that in the editor because I created this little onDraws gizmo function. Basically all this does is just draw like a little wireframe cube. This doesn't show up in your final game when you publish it or anything. It's just for Unity editor for us to see how big the box is. And then the layer mask to see which objects we want to check for, right? Basically everything. And then an update loop, right? So in update, we take the box center and we check everything that overlaps with it. So we do physics 2D and we find anything that has a collider, right? So pretty much all of our game objects so far have colliders on them. And then we just destroy the game object, right? So that's all this thing does. So it follows the camera and just kind of destroys everything in its path, right? The only thing I had to change was in the prefabs. In my buildings prefab, I had to add a, on like the sprite, I added a little box collider 2D, and I just set all of these to be trigger. So that's all I did. That's all I changed here. So if you guys do that, set these to as trigger, it's not going to do anything except for be caught by this deleter box. So if we hit play now, you can see that everything that's in the path of this red deleter box just gets deleted, right? Yo, congrats on making it through the tutorial. Don't forget to like and subscribe, bruh. So anyway, there's a ton of ways the PizzaSkater game can be improved. We can add sound effects, maybe multiple levels, and a better point system. But leave a comment below if you have any suggestions on stuff to add, or if you want a tutorial on something specific. Let us know how your game turned out. Thanks for watching, and catch you in the next one.